Auroras are gorgeous. When we look up at the dancing lights of an aurora, we're witnessing much more than just a beautiful light show. We're seeing evidence of a complex interaction between our planet and the sun, one that scientists are working hard to understand. Earth's magnetic field forms a protective bubble around our planet, shielding us from the constant stream of charged particles flowing from the sun. But this shield isn't perfect. At Earth's polar regions there are special entry points called magnetospheric cusps, where our magnetic field lines bend toward the ground, creating doorways for solar particles to stream directly into our atmosphere. These cusps are where the magic happens. When charged particles pour through these openings, they collide with atoms in our atmosphere, creating the spectacular light shows we know as the northern and southern lights. But there's far more going on than meets the eye. Professor Jasper Halekas from the University of Iowa explains that these cusps are scientific treasure troves. They offer rare glimpses into phenomena like magnetic reconnection, where magnetic field lines break and rejoin, releasing enormous amounts of energy. To better understand these processes, NASA has developed the Analyzer for Cusp Electrons, or ACE, as part of the TRACERS mission. This sophisticated instrument will orbit Earth, passing directly through the northern cusp region to measure high-energy electrons moving both downward and upward. What makes ACE special is its speed. The instrument can capture events lasting mere milliseconds, essential for studying the dynamic electron activity in cusps, where changes happen incredibly quickly. Using electrostatic optics and a sensitive detector system, ACE takes rapid snapshots of electrons before they zip away. When the spacecraft's orbit aligns with Earth's magnetic field, ACE can observe electrons coming from nearly every direction in a single sweep. This comprehensive view increases the chances of detecting rare changes in electron flow that might otherwise go unnoticed. But why does this matter? Understanding electron activity in the cusps helps us decode space weather, the conditions in space that can affect our technology and daily lives. When electrons with moderate to high energies enter the cusp zone, they pump heat into the ionosphere below. These changes can ripple further, affecting global currents, triggering aurora activity, and potentially impacting satellite orbits and radio communications. By combining data from ACE with other instruments measuring fields, waves, and various charged particles, scientists hope to create a more complete picture of what shapes our near-space environment. They'll be able to distinguish between local events and those triggered by sudden gusts of charged particles from the sun. The cusp region represents a unique laboratory, a place where Earth's magnetic protection is at its thinnest, allowing us to directly observe how our planet interacts with the solar wind. By studying electron behavior in these regions, scientists are essentially looking through windows into the complex dance between Earth and Sun. As we continue to rely more heavily on satellites and other space-based technologies, understanding these interactions becomes increasingly important. The beautiful auroras that have captivated humans for millennia aren't just light shows, they're visible reminders of the invisible forces that connect our planet to the cosmos, forces that TRACERS and ACE will help us understand more deeply than ever before. For more on this story, find a link to the article on Earth.com in the description.